So talking about these bass in Reed's Lake here, this is going to bring us to the first part of our lesson. And we're talking about percent change, which is, getting a percentage to explain how things change. Raw number's pretty easy, right? Plus 90 minus 90 for the number of bass in the lake. I don't know why I left that like that so long. Okay. So, and Joe did a great job explaining. He said, well, if we're talking percentages, our starting amount here to here is going to be different than starting here going here. Because percentages are relative. You need a percentage of something, and the of something's changing. So while it looks like the same change, and it is the same raw number change of fish, the change in terms of percentage is not the same. So let's take a look at how to do it. Here's the percent change equation. It is the amount of change divided by the original. You might see some different wording in a textbook, maybe a little complicated. I say change divided by original. Now for this portion up here, the amount of change, that is kind of like an absolute value situation. Are you seeing that? When you explain how, if something changed from 1 to 2 or 2 to 1, the amount of change is still 1. Right? And talking about these bass from our warm-up, the amount of change either way is 90. Right? That's how much it changed by. That's like an absolute value situation. So when I'm using my numbers in the equation, I always do, and you don't have to, but I always do larger absolute value minus smaller absolute value. Because it's pretty intuitive. Is this going to be an increase or decrease from there to there? Increase. And from here to here, is that going to be an increase or decrease? Decrease. Yeah, so it's like an intuitive thing. So you don't need to worry about getting your answer to be positive or negative. You might see that in a video or a textbook. So let's get a percent change from 2 years ago to last year. And I would do that by finding the amount of change divided by the original. And then you're going to need to be a little careful with your calculator. How I type this in is I write 1,002 minus 912, and then I hit the enter or equal button to get 90. And then I push divide by 912. You can also put your numerator in parentheses. And that's going to give me 9.9%, close to 9.9. So there to there is about 9.9% increase. And you have to say whether it's an increase or decrease. Because that's, I don't know if you heard me say this before, but math is communication. And that's telling us whether it's increasing or decreasing by 9.9%. And one thing that would work is you would take this value here multiplied by 0.099. It would give you the 1,002. So let's check out how this change happens. I'm going to do a different color just so I don't have to rewrite the whole page. Let's go with some salmon. So the amount of change is going to look the same, isn't it? Right? We kind of already established it's still changing by 90. But the original is different. If I divide by a larger number, what could happen to my percentage here? Should it go up or down? It's still a change in 90, but now my original is 1,002. That's going to get me closer to 9% decrease. So it's almost a whole percentage difference, right? And the reason why is it's a bigger number. So to make the same raw number a difference, I would need a little bit less percentage. Right? You guys seeing that? Why that works?
If it was 1,012, would it be 1%?
Yeah. Yep. So percentages are relative to what you're taking the percentage of, right? Your whole matters. So like a 9% increase and a 9% decrease mean different things depending on the whole thing. So that's why I like to start with this one, because intuition might lead you to think it's the same increase and decrease, right? I get that, 90 fish. But by percentage, not the same. Like, for another way to think about it is, if you went to a store and they marked up something 20% to sell it, but then you had a 20% coupon, is the value of what you buy it at the same as what they started with? No, because the 20% changes because the whole changes, right?
So you wouldn't be getting as much out of it.
It would actually still be more than the original, right? Okay, well, I think, let's test it out. Let's do it.
Yeah.
Okay, so how much is that? Okay, I want an Under Armour hat, a new one for Christmas. My head got smaller, so my old one's too big. Let's say Under Armour gets that hat. Let's say they get the hat for $10. We're going to use nice numbers, okay? And I'm going to stop recording because this kind of goes with tomorrow's lesson, but I feel like I got you guys doing something. If you're following on the One Stop Shop doc, you'll see a link to just, there's a percent of change worksheet that has some examples on there. We're not going to do all of them, but if you're following along and you want to look on there, go for it. So let's say it's got like original and new. So I'd like to give it a little more context. Original, 58 homes. And new, 152 homes. Okay. So to give this context, maybe you're playing, I don't even know much about this game, Sims. You build houses in Sims, neighborhoods. Do kids still play Sims? All right, let's say you're moving into a new let's say you're moving into a new neighborhood development, which doesn't exist in East really usually. But there were 58 homes in there, and now there's 152 homes in there. Okay? And one way that you could explain this change other than raw numbers is by percent change, which is the amount of change
Divided by
over the original. Okay? Or over the OG. So, amount of change would be 152 minus 58. And the original in this case would be 58. Then it just becomes a calculator problem. And percentages are a great way to try to understand numbers. 152 minus 58 divided by 58, and this is cool. This is 162% increase. And let's make sense of that. 100% increase would be doing what to my number? Doubling it, right? So doubling it would be like 116. So you can kind of check your answers and make sense of things, right? That's why you can have more than 100% increase. Or more than 100% decrease would be doing what? More than,
It'd have to be in the
yeah. Okay. So let's go. I'm going to come up with one on here that doesn't seem to make a big difference, but it is. This happens sometimes at the grocery store. Like, let's say, I'm into canned beans. We did canned beans before, right? Let's say canned beans are like 85 cents or something for this can. They're pretty cheap. And let's say they're on sale for 75 cents. And you might just look at these numbers and be like, that doesn't seem like that good of a deal. Anybody see that? How much is the difference? It's 10 cents, right? So that's a dime, like whatever. But check this out. The amount of change divided by the original.
It's a lot.
I don't know why I wrote a 7 there.
Yeah.
That's like a 12% discount. That's a pretty good discount. 12%? Right? Or even something like 80 cents, but now it's 50 cents.
That's big.
30 cents doesn't seem like that much, but in terms of percentage, right? So it's just, again, I'm going to keep encouraging you. I want you to use numbers to communicate and understand the world around you, right? Because those things can help inform decisions. It happens, an item I notice at the grocery store a lot that the sale price can be bigger than it looks is eggs. Because eggs are relatively cheap, right? So if it goes from like $3.50 to $2.50, that's a big decrease by percentage, even if you're just saving only $1. So again, use these numbers to understand the world around you, and then you can use it to make decisions. I want you to try one more of these, okay? And we're going to do, maybe this is in a, in a pool? I don't know. I don't know what this is. I just have an original and a new. Yeah, I got it. This is Mikey's pool, okay? Oh, this wouldn't be enough for a pool. Mikey has one of those igloo,
Mikey has an igloo.
no, you know those igloo coolers, like those yellow ones?
Mikey Mikey has like.
Mikey's got one of those full of orange pop,
No,
okay?
I have like 8 of them.
And this is how much was in there, and this is how much is in there now, and I want to know the change. If you finish, you're going to work on Khan Academy Algebra 1 course, all right? So again, amount of change over original allows us to explain how something's changing by percentage. It's a way that we can communicate and just get another way of understanding situations.